see. Let's go with graph and label. Number 1, y equals 2x squared plus 8x plus 15. All right, we're graphing fully, and we're labeling everything on it. Domain, range, every single thing about it. All right, so first I'm going to get my data. That would mean I'm going to find my AOS. X equals negative b over 2a. I already know x is negative 2 for that vertex. I just need to find out what the y value is. So I'm going to do f of negative 2 and substitute that into the function. What did we get for negative 2? 7? Everybody agree? Okay, so my vertex is at negative 2, 7. Yeah, I should have as well. That's okay, however you want to do your graph. All right, so that's AOS, vertex. All we need is 1 point. Where am I going to find that 1 point? Huh? So the y-intercept would be when x is 0. So f of 0 equals what? I can, when it's in standard form, that's going to be 0 times 2, 0 times 8, and that leaves the 15. That's the only time that you can see it is when it is in standard form. That's 15. There's symmetry now for that point. I am 2 units away, so 2 units away on this side. Remember, the parabola is not going straight up and down. It is going out. Then my vertex needs to be labeled negative 2, 7. My y-intercept is labeled with the number 15 up there. I've got my AOS labeled with my equation, x equals negative 2 way down at the bottom. What are some other questions that we can answer to know this function fully? We'd want to know what the domain was. Domain and range. What's the domain of this function? Which variable does domain have to do with? It has to do with the x variable, right? So if I just run my pen along the x-axis, is there any place it's not going to exist? No, because it's going from here, it's going out. So that's all the reals. That would be from negative infinity to positive infinity then. So the domain has to do with the x variable. The range has to do with the y variable. If I run my pencil along the y-axis, is there any place that this doesn't exist? Down here it doesn't exist. Well, when does it start to exist then? At 7, and it goes to where? Very good. So 7 to positive infinity. Does 7 get a square bracket or a rounded bracket? It's square because it includes the number 7, and then infinity gets a rounded bracket. Because how do you? Y equals x plus 1 squared minus 2. Now, again, we already have in our notes the 3 different kinds that you can look at. But I needed to go back and touch on this one specifically because some people are taking this problem. What form is this one in? This is not standard form. So if it's called vertex form, then you should use that form. Some of you took vertex form and you expanded this out, did all that math, and then put it back in standard form. I mean, I appreciate all your work. I do. Gave me a whole entire page for one problem because you expanded it out and there was so much work to go through, and then you had to go through all this. So after you expanded it out, then you had to go through all this. Well, why do that? when it's in vertex form. We looked for the AOS and then the vertex. It took us 2 steps to get there. I can see the vertex right now. I don't have to do any of that. So what is the vertex? If this is vertex form, what's the vertex then? Very good. X minus h squared plus k. HK is the vertex. That's the formula that's used. HK, so it's not positive 1, it's negative 1 because of the negative sign that's in the formula. It always changes the sign. So it's negative 1, negative 2. Boom, you've got your vertex. So, negative 1, negative 2. There's my vertex. If I have the vertex, what else do I have? The AOS. AOS. Well, what is the AOS? Negative 1. X equals negative 1. And so I only need one more point. Where am I going to get that point from? I have the vertex. I just need one more, and then I can use the symmetry. Again, the y-intercept, right? So the y-intercept is when x is 0. So f of 0, and I'm putting it right into the equation that's there. F of 0 equals 0 plus 1 squared minus 2. 0 plus 1 is 1. 1 squared is 1 minus 2. Hardly any work when you're in this form. Look at this, a little tiny piece of the paper versus all of that for standard form. And so we get f of 0 equals negative 1. Use my symmetry and graph. And my AOS, x equals negative 1 is labeled. Everything's labeled, then it's domain and range. Go ahead and write down what your domain and range is. Range goes from negative 2 to positive infinity. All right, that's all I'm saying about graphing. You have a foldable in your book, quick check that we went over to make sure that you had those 3 forms right here. So here's your quick check that we already did of the 3 different forms. The only one I haven't done is intercepts. Okay. All right. The next problem that we're going to do is write quadratic function in standard form. So write in standard form. Problem 3. Negative 2 times x plus 3 times x minus 7. I'm going to start with the parentheses first. Starting with the parentheses, we can see the first term, x times x, x squared. We can see the last term, 3 times negative 7, negative 21. It's that middle term that I want you to start being able to get quickly, okay? And what you're doing is you're just adding these 2 numbers together. Remember, it's adding for the middle term and multiplying for the last term. So what's 3 minus 7? That's negative 4x then. It adds to the middle term and multiplies to the last term. And then multiply through with the 2. Negative 2x squared, positive 8x, positive 42. Huh? Yes, problem 3 and 4. We just did 2 graphing problems. So we know a plus b squared, that's the formula. A plus b squared equals a squared plus 2ab plus b squared. 2ab plus b squared. So we know the first term is a squared. We're going to leave the 5 there. We're going to multiply out the binomial squared first. So what's the first term? It's a squared. So the first term, x squared. I know what the last term is going to be. Last term is b squared. So here's my b term. I square it. Here's my b term. I square it. 6 squared is 36. Positive 36. The middle term. These are two problems that I want you to do because we're going to use this in chapter 2. We're going to use it for the rest of the school year, factoring, okay, and multiplying out. So I want you to get used to adding your terms and multiplying your last term. And then when it comes to this type, the middle term is 2ab because there's always two terms on the inside that are the same. So it's 2 times a times b. That's 2 times x times positive 6. What's 2 times 6? 2 times 6 is 12 times x. 12x. Then we still have a minus 2 out back. So I'm showing you how to use your formulas. Again, you could put them next to each other and you could just multiply them out on a quiz and a test. But while we're in class, I want to try to help you be quicker at your numbers. Now what would I do on this problem? Very good. You got to use the distributive property and multiply before you're adding and subtracting. So multiplying by 5, we have 5x squared. 5 times 12x would be 60x. And then 5 times 36. 6 times 5 is 30. Carry the 3. 5 times 3 is 15. Plus the 3 I carried is 180. Minus 2 is still there. My final answer, 180 minus 2. Solve the equation. What degree is this problem? How many answers do you expect from a degree 2? 2. Okay, so how do we solve equations? This would be last class. We had the, huh? Yes, how do I solve for x? What's the technique that we have? Huh? What? Yes, in check. Yes. Factor. Factoring. That's the only technique you really have right now. It's factor and solve. Let's see if you can factor this. Factoring. Factor and solve. Looking for factors of 24 that are going to add to a negative 11. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which one of these can I get to add to a negative 11? Negative 3, negative 8. They add to negative 11, and then they multiply to a positive 24. X minus 3, x minus 8, and solve. X equals, do I need to spell this out? Or do we get how to solve from here? Beautiful. Set these both equal to 0 and solve. X equals 3 and x equals 8. 4x squared plus 20x plus 25. Factor and solve. I guess the first thing I would look for would be monomial factoring. Is there something I can pull out to make my life easier? Do they have anything in common at all? 4x squared, 20x, and 25. Do they have anything in common? Unfortunately, no. So we'll be doing any monomial factoring. I'll give you a couple of minutes to work on this. You can look back at your notes for factoring and see if there's a method there that you like. You got the box method, the asterisk method, whatever you want to do to see about factoring this one. All right. For myself, I would just use guess and check on this one right here, but I know that you guys are still new at factoring. So we know that the box method and the star method, they're pretty similar in how they do their method. What I needed to start off with was what I needed to start off with was by multiplying my a times c. That's 100. Then I'm looking for factors of 100 that are going to add to 20. And so when I go down through and look, I see nothing. I thought I saw something because I don't see anything yet. Let's see, 6, 7, and 6, 7, 10. There we go, 10 and 10. That'll work. 10 plus 10 is 20. 10 times 10 is 100. Remember, you got to multiply your a times c. You need AC. So 10 times 10 is 100. So now that I found what works, I'm ready to go. I know in the first box is my first term. In the last box is my last term. And then these two are the ones that go in here. So 10x and 10x. Now the next thing I would do would be just looking for the common factors that I can pull out going in the rows and columns. So what can I take out of these two right here? They have a 2 in common and an x. 2x. What do they have in common here? Just a 5. And then I have to look this way as well. What do they have in common this way? 2x. And then here, 5. So those are my factors. 2x plus 5 times 2x plus 5. So 10x and 10x is 20x. And then 2x times 2x is 4x squared. 5 times 5 is 25. Those are my factors right there then. And again, this is a pretty easy problem to guess and check, but it is good to have a technique. I had you try all of them so you can see there's many different techniques, but you should really pick one that works best for you. When it's tough, that's the only time I use this. This was not a tough problem, but for you it probably was because you're still new at factoring. You're going to get a lot more practice in chapter 3 with your factoring, so we're not getting away from it. So we have 2x plus 5, 2x plus 5, and I need to solve this. So 2x plus 5 equals 0. They're both the same, so I don't need to do it twice. Shift the 5 over, and I get 2x equals negative 5. Divide by 2, we get x equals negative 5 halves. So one of the x-intercepts is at negative 2.5. Actually, both of the x-intercepts are at negative 2.5 because we have the same factors. How do I write my answers so that everybody knows there's 2 answers and I'm not getting points off for just having one answer? You can write it twice, or you can write multiplicity too. You should get in the habit of writing the word multiplicity, because when we get to chapter 3, you're going to have multiplicity 3, multiplicity 4. So get in the habit. I wouldn't mark it wrong if you put negative 5 has, because technically it's true. But it'd be better if you could start using the word multiplicity to say that for the next chapter. So what does that mean then? You don't have to graph it, but it's at negative 2.5. What does that mean for the parabola? It means that it's coming down and it's bouncing off. Those are words we're going to be using in the next chapter. When you have an even multiplicity, it approaches the axis and then bounces off. Odd ones go through, but you don't need to know that right now. All right, so that's your review for your test on sections 1.1 through 1.4. I want you to right now open up to your digital textbook to make sure you can access your quiz and your book. Remember that if you can't get into your digital textbook, you saved it on your website. You saved the password, you saved the digital homework textbook. I also left you a link in Google Classroom that you could click on to bring you to that website. But the question is, are you going to know your username and password?